All right, so on Monday, we started talking a little bit about transformations of functions. Okay, we had all our different types of functions. I gave you the list of the parent functions and what those graphs looked like and their tables. So we're going to keep going with that. We saw the equations, we looked at what the A, the B, the H, and the K did to all of those graphs just by kind of exploring with that a little bit. So now what we're going to actually do is apply that. So now that you know what those numbers do to a graph, then you need to actually be able to look at an equation and graph it. So we're going to do that in a couple of different ways. So we're going to start out just with one way today, where we're looking at every single different transformation individually, just to kind of get an idea of what those transformations look like as you do each one, and then what the end result is going to come, what that will be coming from all those different transformations. Eventually, we will shift into just being able to look at the equation and graph it immediately. But today we're going to kind of look at it step by step. Okay, so learning targets is to be able to graph the functions using transformation. So horizontal and vertical shifts we talked about, stretches and compressions, so shrink or stretch, and reflections about the x or the y axis. Okay, so we're just going to go through really quick as a refresher of what all these different transformations do. So here we have the parent function of f of x equals x squared. So just as a refresher, this is what that parent function looks like. So it has the points 0, 0, 1, 1, 2, 4, and negative 1, 1, and negative 2, 4. So if we were going to take that parent function, x squared, and subtract 2 from it, so we're subtracting 2 on the outside of the function. So that is going to move my function down 2. So all of the points are moving down 2. Okay, so that's a vertical shift. So if something is added or subtracted to the outside of the function, that says that we're moving it up or down. Okay, so we're adding or subtracting to the y values. Okay, so that'll move your graph up or down. Keep going with the same parent function. So we have f of x is equal to x plus 3 squared. So since I have this squared, okay, I have an x squared in this function, that means my parent function was f of x equals x squared. So that's my original function, the parent function without any transformations being applied. And if I want to add 3 on the inside, so it's in the parentheses, it's on the inside of the function, that means I'm going to subtract 3 from the x value. So I'm going to move to the left 3. So when it's on the inside, and we talked about this a little bit on Monday, when it's on the inside of the function, it moves opposite of what you see. So that horizontal shift, we're moving either left or right. So if you see a plus, that means we're going to subtract from the x values. And if you see a subtraction, that means you're going to add to the x values. So when it's inside the function like that, you're doing the opposite. Here we have a combination of both. Parent function is still x squared, and I'm adding 3 to the x's. I have that minus 3 in here, adding 3 to the x's and subtracting 1 from the y's. So your new equation would look like, your new function graph would look like that. All right, let's try it with a different parent function. So we have f of x equals the square root of x. So remember that was just 0, 0, 1, 1, and 4, 2 was our parent function points for that. So if we were to put a negative on the outside of the function, so in other words, we're multiplying by negative 1 on the outside of the function, that's going to reflect it over the x-axis. So reflect across the x-axis. We take our y values and we multiply those by -1. So it's on the outside of the function, so that affects our y values. So when we start with a point xy, the x's stay the same and the y values get multiplied by -1. Reflect across the x-axis. If we have a negative on the inside of the function, so multiplying by -1 on the inside versus the outside, that's going to be a reflection across the y-axis. So that one we have where we're going to multiply the x values by -1. So it's on the inside of the function, which means the x values get affected. So if I have a point xy, we're going to multiply the x's by -1 and the y's stay the same. So that's a common theme here. Anytime there's something going on inside the function, it affects the x's. Anytime there's something going on the outside of the function, it affects the y's. Here we have a few things. So when we start practicing with this, I'm going to have you guys write down, when we have more than one transformation, I'm going to want you to write down what each of the transformations are. So we're going to start here. Always start with the parent function, which I already have graphed. So you always need to know what the parent function is first, and in this case, it's f of x equals the square root of x. So since our function has this square root in it, we know that our parent function was f of x equals the square root of x. Secondly, our transformation starts with a negative on the outside. Now remember, when things are happening on the outside of the function, it affects the y's. So what we're doing here is multiplying the y values by -1. So that will reflect across the x-axis. Our next transformation, we have this 2. We're adding a 2 on the inside of the function. So whatever happens on the inside of the function affects our x values. So we're subtracting 2 from the x values, which moves the graph to the left. And lastly, we have this 4 that's being added to the outside of the function, so that affects our y values. So we're adding 4 to the y values, which moves our graph up. So when we put that all together, we're going to get a new function that looks like that. Okay, so reflected across the x-axis, then we subtracted 2 from the x value, so it moved over to the left, added 4, so it moved up the y values. Okay, let's look at a new parent function, f of x equals the absolute value of x. So that was our v function. And let's say we multiply by a 2 on the outside of the function. So again, when we're multiplying, when something is going on the outside of the function, that affects our y values. So that's, we're going to multiply all of our y values by 2, which makes our graph skinnier. Okay, it shrinks that, or it like stretches that graph up so it looks a lot skinnier. So that's a scale vertically by a. So we scaled this graph vertically by 2. In other words, we multiplied all of our y values by 2. Okay. So start with a point xy. X's stayed the same, but all of our y values were multiplied by 2. Okay, if we have a graph with a scale factor on the inside of the function. So 1/2 is being multiplied by x on the inside. So again, when it's on the outside, it affects the y values. When it's on the inside, it affects the x values. So what that's going to do is kind of compress our graph down. Okay, so by a half, everything gets compressed by a half. But the tricky thing is that when you scale horizontally, in order for it to compress like that, you need to multiply by the reciprocal. Okay? So when we scale horizontally, we're multiplying by 1 over b. So in this case, b, this is our b value. B is equal to 1/2. So when we try to figure out what our points are, we're actually going to multiply by 2. And that's the reciprocal of 1/2. So we're multiplying the x values by the reciprocal of b. Okay, multiplied by the reciprocal. So we multiplied all the x values, in this case, by 2. Now here's where it gets a little bit tricky, so really pay attention to when I do this one. We have f of x is equal to negative absolute value of 3x plus 6 plus 2. Now, the b value is what you multiply everything in the middle of the function, okay, on the inside of the function. Okay, so what we have here is 3x plus 6. Well, our b value is 3. So when you have something on the inside of the function, you need to take out that b value to figure out what our horizontal shift is. We did not shift this by 6. Okay, and let me show you what I mean. What you have to do when there is a b value on the inside is we need to factor out that 3. 3 is our b value. We need to factor it out to figure out what our horizontal shift is. So we're actually subtracting 2, okay, for the horizontal shift. So again, we need to factor out that 3 to figure out that our horizontal shift was actually subtracting 2. So anytime you have that b value on the inside, like that, you need to factor it out to get the true horizontal shift. So in this case now we'll go through our transformations. We have our parent function is f of x equals the absolute value of x. So we have these absolute values in our function. So that tells us what our parent function is. Okay, next we have a negative on the outside of the function. So when it's on the outside of the function, it affects the y values. So we multiply the y values by -1. So in other words, it's a reflection across the x-axis. The next thing we're going to do is we have this scale on the inside of the function, so we're multiplying by a 3 on the inside of the function. When it's on the inside, it affects the x values. So multiply our x values by the reciprocal of b. So since there's a 3 in there, we're multiplying by 1 over 3. All right, next we have this plus 2 on the inside, which means we're going to subtract 2 from the x values. It's on the inside, so we're we're subtracting from the x values. Okay, so there's that theme here. When it was 3 on the inside, when we're multiplying by 3 on the inside, then what you actually do is the opposite, multiply by a third. When it's adding 2 on the inside, you actually do the opposite, subtract 2. Okay, so when it's on the inside there, we're affecting the x's, and we always do the opposite of what we see. The last one we have, adding that 2, so add 2 to the y values. And our end is going to look like that. Our final answer is going to look like. Okay, so let's go ahead. So here's just kind of a refresher of what we just talked about. So when you have a function, your a value on the outside is a vertical scale. Okay, so you multiply by that, multiply all the y values by a. If it's negative, it reflects across the x-axis. The b, multiply all of your x values by 1 over b. So we do the opposite of what we see. If it's negative, it reflects across the y-axis. Horizontal shift on the inside of the function, and a vertical shift on the outside of the function. So that's kind of a nice little summary of what we have for all of our different transformations. So if you want to pause really quick and so you can have that written down, you can. So it's nice and written down all in one place if you need that. Let's do a couple of examples. So we're going to start with the function f of x is equal to 1 over negative x plus 2. So when you come to class next time, you're going to have an assignment where I'm going to give you a series of different functions we're going to have to graph for the transformation. You're going to have an answer sheet where it will look like this. It will have the function, it will have the blank graph for where your final answer goes, and it will have space for you to write down what all the transformations are. That's your answer sheet. Underneath that, you will have spaces so that you can show each transformation in a graph, and I'll show you what that's going to look like right now. Okay, so this is like what our answer sheet would be. So I'm going to start by looking at my function and ask myself, what is my parent function? So if you need to look back at your sheet that has all your parent functions in it, you can do that. Our parent function in this case is going to be f of x equals 1 over x, that reciprocal function. Okay, then we have our transformation. Our first transformation right here. I'll put a number 2 so it goes with it. So we have the parent function. First transformation is that negative with the x. So that's on the inside of the function, not on the outside. So that affects our x values. So we're going to multiply the x values by negative 1, which is a reflection across the y-axis. Okay, oops. Too many C's. Then the next one we're going to have is adding a 2 on the outside of the function. So if the 2 was in the parentheses with the x, that would be considered inside the function. This 2 is on the outside. So we're adding 2 to the y values, which is going to move our function up. So that's all the transformations that we're going to do. So before you graph the final answer, what you're going to do is you're going to go to the sheet that has just has a series of graphs. So I have 3 transformations that I'm doing, so I have 3 graphs. I'm going to show each step in order. Okay, so the first one always is our parent function. So our parent function is 1 over x. So I'm going to go ahead and write the table out for my parent function. So I have the points negative 1, 1, 1, and negative 1, negative 1. I also have 2 asymptotes on this graph at y equals 0 and x equals 0. So that's going to be important to keep in mind when we're doing our transformation. Okay, so that asymptote is here, x equals 0, and y equals 0. So we have the point 1, 1, and the point negative 1, negative 1. So it's just a matter of you're going to need to memorize what all these parent functions are. From there you can apply the transformation, but you're going to need to have the parent functions memorized. All right, from there we had a multiply the x values by negative 1. So in my new table, I'm going to multiply my original x values by negative 1. So now I have negative 1, 1, and the y's stay the same. Negative 1, 1, and 1, negative 1. So I'm going to graph that. So my asymptotes stay the same. We have y equals 0 and x equals 0. Nothing happens to those. So y equals 0, x equals 0. Now I have negative 1, 1, and 1, negative 1. So as you can see, my graph was reflected across the y-axis. Okay, so both of those sides reflected right across. The last thing we do is we had an add 2 to the y values on the outside, so it's supposed to shift up 2. So from our very last table, we're going to add 2 to those y values. So x stays the same, and then we add 2 to our y values. So 1 plus 2 is 3, and negative 1 plus 2 is 1. The asymptotes, when we're adding and subtracting, also get affected. So we're not doing anything to the x's. So x equals 0, but we added 2 to the y's. So my y asymptote is also going to shift up. The whole graph shifts up 2. So we have x equals 0 and y equals 2. We have the point negative 1, 3, and 1, 1. Okay, so you can see how my whole entire graph shifted up. Okay, so this here now is your final answer. That is all 3 of those transformations put into one. So you go back to your answer sheet and put in your final answer. So I have asymptotes, negative 1, 3, 1, 1, and that is my final graph. So you use the graphs on the other sheet to do each transformation. Okay, I will expect you to show both the tables and the graph for every single transformation. Then you give me your answer on the answer sheet. Okay. Let's do one more. Okay, so this one, we have our parent function. We have a cubed in our function, which means our parent function is f of x equals x cubed. Again, we have this half value on the inside of our function. So whenever you see that, you need to make sure that you factor out that b value so you can figure out what your actual horizontal shift is. So I factored out a 1/2 and got x plus 2. Okay, so that is going to be the function that I'm going to look at for when I do my transformations. All right. So the first one we have here for number 2 is a multiply the y values by negative 1. So we're reflecting on the x-axis. The next one we have is going to be that b value. We're multiplying on the inside. And remember, whenever it's on the inside, it's the x values, and you multiply by the opposite of what you see. So we're multiplying by 2. Then we have this 2 here. That's on the inside, so it's opposite of what you see. So we're going to subtract 2 from the x values. And lastly, we have that minus 3 on the outside. So we subtract 3 from the y values. All right, once you have that all written down, then you go to your sheet that has all of your different graphs on it to show every table and every transformation. Okay, so again, I will expect to see every table and every transformation. So starting with the parent function, so it was f of x equals x cubed. So -2, -1, 0, 1, 2. If you cube all of those, -2 cubed is 8, -1 cubed is 1, 0, 1, 8. Okay. So -2, 8. A little bit up here. -1, 1, 0, 0. Oops. Hold on. Totally did that wrong. -2 cubed is -8. -1 cubed is -1. Okay. So there's our parent function. The first transformation we had was multiply our y values by -1. So every y value over here on this table is going to get multiplied by -1. X's stay the same. And then graph that. -2, +8. So you can see we reflected across the y-axis. Okay. Our next transformation was multiply the x values by 2. Okay, so we had that 1/2 on the inside, so we're multiplying the x values times 2. So from this table over here, all of the x values get multiplied by 2. And all the y values stay the same. So -4. Alright. Okay, so that compression, when you multiply by the x values, it compresses it, kind of squishes it down a little bit. Next transformation was a subtract 2 from the x values. So starting with what we have in our green table over here, we're subtracting 2 from those x values. So -4 minus 2 is -6. -2 minus 2 is -4. -2, 0, 2. All the y values stay the same. So we moved to the left 2, and very last we're going to move down 3. So all of our y values, we subtract 3. So all the y values from this black table that we just finished with, x's all stay the same. And we subtract 3 from our y values. And that's going to be our final graph. Alright, so once you get all of your transformations graphed and all of the tables on there, take what you have for your final answer and go back to your answer sheet and graph your final answer. And that will be your graph of f of x equals x cubed with all of your transformations applied to it. Okay, so again, in class, next time I see you, you're going to be doing a worksheet where you have a series of functions like this, and I will expect you to have each of the individual graphs with the tables. Okay, so make sure you have your parent function paper with you so you can look at that to see what parent function you need to start out with. Write out all of the transformations, each graph transformed as you go along, okay, step by step with the tables. Okay, so I will see you guys next class.